Okay, so good morning everyone. So our first topic it will be a perspective on predictive analytics. Okay, so the difference of data and information is that data does not have a specific purpose, while information carries meaning that has been assigned by interpreting data. So it says here that data alone has no significance while information is significant by itself. And data never depends on information while information is dependent on the data. So data is an information that is being collected, whereas information is an information that is processed. Okay, so the difference between information and knowledge is information is refined data, whereas the knowledge is useful information. So this serves as it that information improves representation and knowledge increases consciousness. So the outcome of information is comprehension, while the outcome of knowledge is based on understanding. Now we have here a data, information, knowledge, wisdom. This is a model that is used for discussion of data, information, knowledge, wisdom, and their interrelationships. So this represents structural or functional relationships between data, information, knowledge, and wisdom. Okay. So analytics is defined as the extensive use of data, so statistical and quantitative analysis, explanatory and predictive modeling, and fact-based management to drive decision making. So this is all about the discovery, interpretation, and communication of meaningful pattern in data. And analytics is all about providing the business users with better insights, particularly from operational data stored in transactional systems. So fortunately, data mining, analytical applications, and business intelligence systems are now being better integrated with transactional systems. So the main components of a typical business analytics dashboard includes: first, we have the data aggregation. So prior to analysis, data must first be gathered, organized, and filtered either through volunteer data or transactional records. Second is data mining. So data mining for business analytics sorts through large data sets using databases, statistics, and machine learning to identify trends and establish relationships. Third, association and sequence identification. So identification of predictable actions that are performed in association with other actions or sequentially. And lastly, we have the text mining. This explores and organizes large, unstructured text datasets for the purpose of qualitative and quantitative analysis. So, the essentials of business analytics are typically categorized as either a descriptive analytics, which analyzes historical data to determine how a unit may respond to a set of variables. Now we also have the forecasting. So the forecasting analyzes historical data from a specific period in order to make informed estimates that are predictive in determining future events or behaviors. Then predictive analytics. So predictive business analytics uses a variety of statistical techniques to create predictive models which extract information from data sets, identify patterns, and provide a predictive score for an array of organizational outcomes. Then optimization. Once trends have been identified and predictions have been made, businesses can engage simulation techniques to test out best case scenarios. Then data visualization. It provides representations such as charts and graphs for easy and quick data analysis. So predictive analytics means understanding the future. It can be used for forecasting, hypothesis testing, risk modeling, and propensity modeling. So this looks into the future to provide insight what will happen and includes what if scenarios and risk management. So the pattern found in historical and transactional data can be used to identify risk and opportunities for future. So the uses of many techniques from data mining, statistics, modeling, machine learning, and artificial intelligence to analyze current data to make predictions about the future. But it is important to remember that there is no statistical algorithm that can predict the future with 100% certainty. We only use statistics to have a guide to forecast insights because the foundation of predictive analytics is based on probabilities. Okay, now we have the processes involved in using predictive analytics. First, we have the data. So we need the data to be collected. The data repository is needed to access for essential data. Then second, analyze. We need to analyze the data we collected, analyze data model to assess the query and the data collected in the process, then provides predictions. In this step, predictions are now provided so that business users can actually define and track the next steps on their business analytics before it will happen. And lastly, the smart decisions. So we need to decide the ways on how we analyze the data. So analytics can allow managers to create a better and smarter decisions. Now we have the competitive advantage. So first, growing volumes and types of data and more interest in using data to produce valuable insights. And faster, cheaper computers, easier to use software and tougher economic conditions and a need for competitive differentiation. So how predictive analytics work? So the term predictive analytics describes the application of a statistical or machine learning technique to create a quantitative prediction about the future. So frequently, supervised machine learning techniques are used to predict a future value or to estimate a probability. So predictive analytics is the process of using data analytics to make predictions based on data. This process uses data along with analysis, statistics, and machine learning techniques to create a predictive model for forecasting future events. So frequently supervised machine learning techniques are used to predict a future value. So we can say how long can this machine run before requiring maintenance, or to estimate a probability like how likely is this customer to default on a loan. So predictive analytics starts with a business goal to use the data to reduce waste, save time, or cut costs. So the workflow, it contains the access and explore data, whereas we can see here the files, databases, and sensors. Then pre-process data, the working with messy data, data reduction, transformation, feature extraction, and then develop predictive models. Okay, and then develop predictive models. It includes model creation, parameter optimization, and model validation. And then the integrate analytics with systems. So we have desktop applications, enterprise scale systems, and also the embedded devices and hardware. Okay. So developing predictive models uses a predictive modeling uses mathematical and computational methods to predict an event or outcome. So examples include the time series regression models for predicting airline traffic volume, or predicting fuel efficiency based on a linear regression model of engine speed versus load, and remaining useful life estimation models for prognosis. So these models forecast an outcome in some future state or time based upon changes to the model inputs. So using an iterative process, you develop the model using a training data set and then test and validate it to determine its accuracy for making predictions, and you can try it out a different machine learning approaches to find the most effective model. Now we have the methodologies involved. First, we have the logistic regression. It is a statistical analysis method used to predict a data value based on prior observations of a data set. And then time series analysis. It is an illustration of data points at successive time intervals, and then the decision trees. It is a graph that uses branching method to illustrate every possible outcome of a decision. Now, the rise of real-time analytics. The predictive models are informed by historical data in real time, or near real time may only be second or minutes old. So in the past, predictive models took time to build and test to exploit those patterns. Then the higher the volume of data, the greater the opportunity to fine-tune and refine the model. So the relevance of a predictive model is dependent on the accuracy of key coefficients and factor variables and the ability to find correlations. And automated analytics algorithms such as the machine learning continuously inform the predictive model and enable it to adjust. So each adjustment can increase accuracy as the algorithm continues to process and analyze. Then examples of companies using the predictive analytics in real time. First, we have grocery stores use data from loyalty cards, ongoing promotions, and historical purchases to offer coupons for items you are likely to buy in the future. And then predictive analytics applied to specific behaviors of customers browsing a website enables delivery of a personalized experience. And then the Google search and Microsoft Bing services use machine learning when they offer alternatives to queries during search. Okay, so operationalizing predictive analytics. So optimizing business processes and reducing operational costs. So organizations can use predictive analytics for decision making, solving problems, business problems, and identifying the opportunities, and then engaging deeper with customer and enhancing the customer experience. So predictive analytics can be used to support major strategic decisions. It's also good for making smaller tactical decisions, the ones that people and machines make on a routine basis. Then identifying new product and market opportunities. So predictive analytics is most effective at the point of decision. And then lastly, reducing risk by anticipating and mitigating problems before they occur. Okay, so predictive analytics has the potential to deliver value in diversity of industries. First, we have energy and utilities. So the use cases is that energy consumption patterns and management, and then financial services. You have the fraud identification, loan defaults, and investment analysis. Then food and beverages, a supply chain. Food and beverages, supply chain demand prediction for creating, packing, and shipping time-sensitive products. Healthcare, the rehospitalization and risk patterns in health-related data. And then insurance, you have the fraud identification and individualized policies based on a vehicle telemetry. Manufacturing, the quality assurance optimization and machine failure and downtime predictions. Transportation, service and delivery route optimization and marketing. Consumer behavior prediction. Churn analysis. Churn, it is the rate of customers moving out or quitting out of the service. And then the consumption and propensity to spend. And also travel is a buying experience optimization, upselling, and customized offers and packages. Okay, so the predictive analytics process and techniques. So we have here the business understanding, the data understanding, data preparation, modeling, evaluation, and then the deployment. So the predictive analytics process begins by understanding the business and preparing the data. A statistical model is then created and evaluated and deployed to handle the data and derive predictions. Okay, so beyond the data modeling, other techniques used by the data scientists and experts engaging in predictive analytics may include: first, you have the text analytics, and then the classification. This is a model that organizes data into preset categories to make it easier to find and retrieve. And then the deep neural networking, which can emulate human learning and automate predictive analytics. Okay. So, how does predictive analytics differ from traditional analytics? So, the difference between conventional analytics and predictive analytics is simple and straightforward, and then the traditional analytics generally focuses on insights impacting here and now. So, predictive analytics aims to allow users to gaze into the near and long term future to pinpoint likely trends and upcoming behaviors. Okay, so these are the tools that can be used to predict various types of behaviors and patterns, such as how to allocate resources at particular times. So you have the Axiom, the IBM, Information Builders, Microsoft, the SAS Institute, Tableau software, Teradata, and the TIBCO software. Okay. So predictive analytics models, we have the customer lifetime value model. It pinpoints customers who are most likely to invest more in the products and services. Customer segmentation model. It is a group of customers based on similar characteristics and purchasing behaviors. Then predictive maintenance model, used to forecast the chances of essential equipment breaking down. And the quality assurance model, so this spots and prevents defects to avoid disappointments and extra costs when providing products or services to customers. Okay. So the algorithms involved in predictive modeling is that the decision tree, neural networks, linear regression, and also the Bayesian network. Okay, so why is predictive analytics important? First, detecting fraud. So combining multiple analytics methods can improve pattern detection and prevent criminal behavior. So as cybersecurity becomes a growing concern, high performance behavioral analytics examines all actions on a network in real time to spot abnormalities that may indicate fraud or zero day vulnerabilities and advanced persistent threats. Second, optimizing marketing campaigns. So predictive analytics are used to determine customer responses or purchases, as well as promote cross-sell opportunities. So predictive models help businesses attract, retain and grow their most profitable customers. Then improving operations. So many companies use predictive models to forecast inventory and manage resources. Airlines use predictive analytics to set ticket prices. Hotels try to predict the number of guests for any given night to maximize occupancy and increase revenue. And predictive analytics enables organizations to function more efficiently. Then reducing the risk. Credit scores are used to assess a buyer's likelihood to default for purchases and are a well-known example of predictive analytics. So a credit score is a number generated by a predictive model that incorporates all data relevant to a person's credit worthiness. So other risk-related uses include insurance claims and collections. Now, when to use predictive analytics? So we use predictive analytics anytime you need to know something about the future or fill in the information that you do not have. Okay, now we have some examples of companies who uses predictive analytics or who applied predictive analytics. So Netflix has announced an expansion into 130 new countries as the most popular internet TV streaming service in the world. And Netflix utilizes the millions of bits of data they have to predict which shows movies users would like to watch through their service. Netflix has a ton of data on their watchers, including the content they watch, how much of it they watch, as well as demographic data. So the company then uses this information to predict which content will likely be successful if streamed through the service, and what the common success points between them are, and also utilizes a well-refined recommendation algorithm to predict what users will likely want to watch. Okay. Next is the Royal Dutch Shell PLC, implemented predictive maintenance driven by AI, or the artificial intelligence, to cut down on the time lost to machine failure. Thus, the systems can anticipate when and where more than 3,000 different oil drilling machine parts might fail, and keep Shell informed about the location of parts at their worldwide facilities, and plan when to make purchases of machine parts. So these systems also determine where to place inventory items and how long to keep parts before putting it into rotation, or replacing or returning them. So the AI powered, or the artificial intelligence powered tools to predict when maintenance is needed on compressors, valves, or and other equipment can autonomously analyze data to help steer drill bits through shale deposits, and will soon be able to identify and alert station employees of dangerous behavior by customers, reducing risk from the drilling platform and the gas pump. So Shell has since reduced inventory analysis from over 48 hours to less than 45 minutes, saving millions of dollars each year, and that thanks to reduced costs of moving and reallocating inventory. Okay, so that would be all. Thank you.